Have you ever stopped to think about the minerals and elements that make up the technology we use every day? One group of elements that often go unnoticed but are essential to modern technology are rare earth elements. Despite their name, these elements aren't actually rare, but they are found in small quantities in the Earth's crust. Rare earth elements, REEs, seem to be in the news again. The uncertainty surrounding metals demand, the mining market, and China's economy all affect the value of rare earth elements. What isn't uncertain, though, is that the demand for them will continue to increase. The rare earth elements, RE, also called the rare earth metals or rare earths according to the USGS, the rare earths are a relatively abundant group of 17 elements composed of scandium, yttrium, and the lanthanides. The elements range in crustal abundance from cerium, the 25th most abundant element of the 78 common elements in the Earth's crust at 60 parts per million, to thulium and lutetium, the least abundant rare earth elements at about 0.5 part per million. The elemental forms of rare earths are iron gray to silvery lustrous metals that are typically soft, malleable, and ductile and usually reactive, especially at elevated temperatures or when finely divided. The term rare earth was coined when an unusual black rock was unearthed by a miner in Ytterby, Sweden, in 1788. The ore was called rare because it had never been seen before, and earth because that was the 18th century geological term for rocks that could be dissolved in acid. In 1794, the chemist Johann Gadolin named this previously unknown earth Yttria, after the town where it was discovered. Over time, the mines around Ytterby extracted rocks that yielded four elements named for the town: yttrium, ytterbium, terbium, and erbium. Though rare earth elements are technically relatively plentiful in the entire Earth's crust, cerium being the 25th most abundant element at 68 parts per million, more abundant than copper, in practice this is spread thin across trace impurities, so to obtain rare earths at usable purity requires processing enormous amounts of raw ore at great expense, thus the name rare earths. The classification of rare earth elements is inconsistent between authors. The most common distinction between rare earth elements is made by atomic numbers. Those with low atomic numbers are referred to as light rare earth elements, LRE. Those with high atomic numbers are the heavy rare earth elements, HRE, and those that fall in between are typically referred to as the middle rare earth elements, MRE. Commonly, rare earth elements with atomic numbers 57 to 61, lanthanum to promethium, are classified as light, and those with atomic numbers 62 and greater are classified as heavy rare earth elements. Now, we'll explore the fascinating properties of rare earth elements and their importance in modern technology. Rare earth elements have a variety of unique properties that make them useful in many different applications. For example, some rare earth elements like dysprosium, samarium, praseodymium, neodymium are highly magnetic, making them ideal for use in hard drives and other magnetic storage devices. Samarium is also used in the treatment of certain types of cancer. Others are highly conductive like yttrium, making them important components in electronics like smartphones and tablets. Another important property of rare earth elements like europium and terbium are their ability to emit light when excited. This is what makes them useful in applications like color displays for televisions and computer monitors. Some rare earth elements, like cerium, are also able to convert ultraviolet light into visible light, making them useful in the creation of sunscreens and other UV-absorbing products. Gadolinium is used in medical imaging, as it has the ability to enhance the visibility of certain types of tissues and tumors. But perhaps the most important property of rare earth elements is their ability to act as catalysts in chemical reactions. Many of the processes used to create the materials and products we use every day require the use of catalysts, and rare earth elements are often the catalysts of choice due to their unique properties. For example, cerium is often used as a catalyst in the production of diesel, also used in automobiles, glass polishing, and the production of steel and aluminum. While lanthanum is used in the refining of crude oil, production of rechargeable batteries, camera lenses, and high-intensity lighting. In conclusion, rare earth elements are essential components in many of the technologies we rely on every day. Their unique properties make them valuable for everything from electronics to clean energy technologies, and their role in chemical reactions makes them essential for the production of many materials and products. However, as demand for these elements continues to grow, it's important to remember the environmental impact of their extraction and use. By working towards more sustainable practices, we can ensure that we continue to benefit from the fascinating properties of rare earth elements without causing harm to the planet.
If you like this informative video, please share with others and please subscribe to my channel for more such content. Thank you for watching.